On this question, it says the amount of pollutants that are found in waterways near large cities is normally distributed with mean 9.2 parts per million, standard deviation 1.7 parts per million. 11 randomly selected large cities are studied. Round all answers to 4 decimal points. All right. What is the distribution? Now notice we have an X and an X bar. So whenever you see X, that means one whatever. In this case, it's one city. And whenever you've got X bar always means, I'm trying to write it here, X bar means the average for the average for in cities, meaning not just one. So that it is important that you understand the difference between X, big old X here, when they give you just regular X versus X bar. X bar, whenever you have a bar over the X, that always means the average of a group. So like if I said to you, what what is your score on the exam? That would be X. The last exam we took, what is your score? Versus if I said, what is the average for the whole class? That would be X bar. So X bar is an average for a big group. I'll just say average. Yeah, let me rewrite that. For a group in like 10 people, 30 students in the class, 40 students in the class, whatever. Whereas X is always one city, one at a time. All right, so what? It says what's the issue? Well, you know what we do here. Let me actually scoot this over. I should have done this better. So X again is one city, person, whatever. Okay, back to it. So we always put the mean here and the standard deviation there, right? And so what's the mean? Well, it says the mean, the average is 9.2, and that's going to be the same thing down there. That doesn't change. That's the parts per million. That's the amount of pollutants in the water. Like how's Fresno's water? You know, um, how's Sacramento's water? How's LA's water? So, or how's a small town's water, Lemore's water, or something like that. Is it different? How much pollutants are in there? So there's the mean and the standard deviation. So now standard deviation, that's it says it's 1.7, so that'll be 1.7. Right, and that's how they got that, and then 9.2. But notice they got something different here. What'd they do? Well, what we do for that, so here's the notes. I'll show you. This is the notes on this material. And notice what it says right down here. Standard deviation. Um, if a question is only for one person or item, enter standard deviation without adjustment. But if the question is for a group of size n, enter as standard deviation divided by square root of n. So there it is. So this, remember, X bar is a group. It's the average of a group. So this is a group of size n. So when I put this in here, this is going to be 1.7 divided by the square root of n. And what's n? 11. That's n. So I'm going to go to the calculator and I'm going to figure out what that is. So let me go here. I've got here's that is not the calculator. Here is the calculator. Just click on the calculator on the home page. I'm going to go to the normal probability calculator. Number 8, normal probability. Pops open slowly. There it is. Okay. I'm going to hit the scientific calculator at the bottom and figure out what was that? I already forgot. It was, oh, it's right here. It's 1.7 divided by the square root of 11. 1.7 divided by the square root of 11. Okay. So it's 1.7 divided by the square root of 11. There we go. 0.5125. See it? Let me come back here. And that's how they got that 0.5126. They just rounded it. Okay. So that's what you have to do. So for a group, the standard deviation changes. You have to divide it by the square root of the group size, n, which is always the group size. Okay, let's go on to question C. There's A and B. Let's go on to C. C says, what is the probability that one, let me circle that for you. One randomly selected cities, waterways will have more than 8.9 parts per million. Okay. 8.9 parts per million. So more than 8.9 parts per million. Well, here's the online calculator. Here's the instruction. This is the notes right here. So this is whenever you have normally distributed, mean, and standard, draw a bell curve, put it on there, and this is the stuff you're going to use. Now notice when you enter stuff in these boxes, notice it says fill in all of the values except one below, and then hit calculate. The last value will then be given to you. So, okay, so probability, what do we put in that probability box? Well, this is only for percentage or decimal probability values, convert to decimal. Whereas P of X, this box up here, this is for regular numbers, not percentage or probability numbers. And then we already know standard deviation and mean, those are easy. Okay, so that's how we're going to use the calculator. So when I go to the calculator for part C, let me just tell you what I'm going to do. I'm going to do P of X. What does it say? More than 8.9. So more than 8.9, because that's a regular number, right? 8.9 is not a decimal or percentage or probability. It's just a regular number. And that's because, and I did it that direction because that means more. Remember, the symbol's on the wide, I mean, the P of X is on the wide side of the symbol. So it's more. Okay, whatever's on the, yeah, that's good enough. And then down below, you know the mean, you know the standard deviation. The mean is 9.2. Standard deviation is 1.7. Now, why am I using that standard deviation, not the other? Well, because it's one randomly selected city. One city, you do the part A, the regular standard deviation. Okay, and then the probability will leave that blank. Just hit the buttons on the calculator, and you'll get the answer, 0.57. Now, part D says for the 11 cities, find probably the average amount of pollutants is more than 8 points. It's like the same question, isn't it? Yeah, but it's for 11 cities, not just one city. So now we're going to go, oh, okay, so again, we're going to do P of X greater than 8.9 because it does say more than 8.9. That part's the same. Mean, that's the same, 9.2. Standard deviation, now that's going to be this one, huh? 0.5126. Why? Because now we're doing a group. So you use a new standard deviation. Put it in there and then leave the probability blank. Hit the buttons on your calculator. You get 0.7208. You know, it might be, yeah, let's go to the calculator and try. So let's see, more than 8.9, 9.2. Let's go to it. More than 8.9. So I'm gonna go here, click more than 8.9, like that. I think that was 9.2, wasn't it? Let me go check. 9.2. Yeah. So I'm just looking around. I'm just going to put in the calculator stuff. More than 8.9, 9.2. Standard deviation. Okay, now instead of putting in the 0.5126, I could. I could. But I'd rather just dial direct. 1.7 over the square root of 11. Let's see if I can just put that in. 1.7 over the square root of 11. See if it'll take it. I'm not sure. 0.7 over divided by, where's my divided by? Oh, I don't even have a square root symbol here, huh? Yeah, no, it's not gonna let me. All right, never mind, never mind. Just kidding. I'll put in that number 0.5126. Let's put it in there. Sure, it'll be good. It'll be wonderful. 0.5126. Where's my point? There we go. 5126. There we go. Calculate. There's the probability. 7208. 7208. Shows a nice little normal curve picture. Bell curve. 7208. 7208. We got it. Shows, did you see the bell curve? How it showed it? Right? So it's kind of nice right down here. You see that bell curve on the bottom? 7208 in there. Nice. Okay. Back to the problem now. Part E. It says, for part D, the one about the 11 cities, is the assumption that the distribution is normal necessary? Answer is yes. Why? Why is it yes? Well, if you look on the notes, let me just tell you the answer right here, right at the top. It says, when n is less than 30, we must be told the data is normally distributed to use these formulas. The assumption of normal data is needed. If n is greater than 30, the number of data is so many that the data will automatically make a normal curve. So we do not need to be told this assumption of normal data not needed. But it's all about whether you're less than 30, more than 30. And you might say, what if it's equal to 30? Well, this is just general rules of thumb. It's never exactly 30. I mean, I guess it could be, and then you can do either one you want, whatever. But like if it's really small, less than 30, and that's what ours is, right? Ours was on, what was n? N was only 11, whereas right here, this is n. This is our n value, n. So that's the number of cities or people or whatever you're in your study. In our study, there was 11 randomly selected large cities, so n is 11. So then that's certainly less than 30. So we're up here. We must be told the data is normally distributed to use these formulas. Yeah, basically, this is the normal probability calculator. A normal curve is a bell curve. How do we know the parts per million pollutants in the waterways is right? That's what this is all about, right? How much pollutants, how many pollutants are in the different waterways near large cities? How do we know it's really like normally distributed like a bell? Because not everything in the world is. Most things are, but how do we know? Well, they told us. I think they told us. And yeah, they said is normally distributed right there. Now the question is, did they have to tell us that? Yeah. Yeah, they did. Or we couldn't be using that normal calculator. Now you might wonder, well, don't they always have to say that? No, it turns out that's what this note is saying. If you have more than 30, it automatically makes a bell curve, even if it just does it automatically. And so you don't need to be told the data was normally distributed. So that's all we're looking for there. Finally, part F. Find the IQR for the average of 11. So you always got to keep straight. Are they asking me about one city? If so, I'm going to use the original standard deviation. Or are they asking me about a group? If you're doing a group, you got to use the standard deviation divided by the square root of n. So in this case, divided by the square root of 11. All right, well, it says right here, we're talking about the average of 11 cities. So n is 11. We're going to have to do our standard. So the standard deviation will be the 0.5126 that we found right there for the group when we took 1.7 and divided by the square root of 11. And we get that 0.5126. All right, so there's our standard deviation. So anyway, we're supposed to find Q1 and then Q3. Now, what's Q1? Well, remember, that's a percentile thing. So like if you have like a number line and you go from 0% to 100%, Q1, here's the halfway. Q1 would be right here at 25%. That's Q1, and then Q3 we'll do in a minute. That's 75% of the way through the data. That's Q3. Remember, it's like a football game, basketball game. Q1's the end of the first quarter. There's halfway. Q3 is the end of the third quarter. Okay, right? It's just a ranking system from 0 to 100. Okay, great. So what? So they're saying, what is Q1? In other words, for these 11 cities, right? Different cities have different amount of pollutants, right? You know, the city with the lowest pollutant to be down, lowest amount of pollutants is down here. The city with the most pollutants is up here, you know. So what's the city that's about 25% away? You know, it's pretty low, right? Pretty low, but actually it's not one city. We want to grab a group of 11 cities and get an average that's pretty low. They've told us that, you know, for all the waterways near large cities, the average is 9.2, standard deviation 1.7. So what is the value that's going to be 25% of the way along? Well, that means when we're going to go to the calculator, you're going to go to the online calculator. We got the P of X. We get the mean, standard deviation, and then the probability. Okay. So what do we know? So they're giving us Q1, and that's 25%. So notice what it says in the notes. Probability is for percent, you know, you put in a percent or a decimal value and you convert to decimal. So this is going to go right here, isn't it? Right? Because Q1 is 25%, so that goes right there. The mean, we know the mean. What was it? 9.2. Standard deviation, we're going to have to put in the 0.5126 because we're talking about a group now, not an individual. And then what are we going to do for the question? We still got to choose less than or greater than. What is it? Well, you want 25% less than what value? You're going to choose less than. Do you see how I knew that? Right? Because if you're at the 25% mark, that means 25% of the cities have less pollutants than you, and 75% have more. Right? Remember what Q1, Q3 is. If I'm at the end of the first quarter in a football game or basketball game, that means 25% of the game already happened before me and 75% still to go, right? So that's the meaning of being 25% of the way through something. 25% is less than you. See why I chose less instead of greater? 25% is to the left. Leave this blank, hit the buttons. Let's go to the calculator. So 9.2.5126. Okay. So that's all the same. I just had to come up here and go less than. Now, if I hit calculate right now, it's going to go, so that meant leave one of the blanks. I go, oh, yeah, yeah. I'm supposed to leave this one up here blank, aren't I? And the probability, I got to change that. That I want to be 0.25 or just 0.25, whatever. There we go. See what I've got right now? I chose, see up here, greater than, between, I chose less than, but I left the number blank. Got to have one blank. And then I put in the mean, standard, and the probability, calculate. And it fills in the probably 8.8542. 8.8542. 8.8543. It rounded, yeah, the last place it rounds. Now, what about Q3? Same thing. Just change this to 0.75 because that's Q3, right? And again, you still want less. You want to say, 75% of the waterways are below this. So just change it to 0.75. Oh, and we got to get rid of this up here now because you got to have a blank. Okay, and then calculate. And 9.5457, it filled in 9.5457. Beautiful. Now, what's the IQR? That's easy. IQR is just Q3 minus just this answer minus just subtract them on your calculator. You'll get that. And so there we go.